Srinivas. I'm working as an assistant professor in IARE college. Today we'll talk about the transactions and the asset properties, related to transaction. Database transaction is a logical unit of processing in a DBMS which entails one or more database access the operations. In a nutshell, database enterprises represent real-world events of any enterprise. Transaction is nothing but a series of steps done in a sequential order. Now, all type of databases access operations which are held between the beginning and end transaction statements are considered as a single logical transaction. During the transaction, the database is inconsistent. When the transaction is being happening, it is inconsistent. Only when the database is committed, the state is changed from one consistent to other consistent. So before transaction, it is inconsistent. After transaction, it is consistent. Between the phase of transaction, the database is inconsistent. So the database initially it is in consistent before the operation. After the operation, it is also inconsistent. But when we start the transaction, between an end transaction, that it is temporarily in the inconsistent state. Now we'll see a few facts about the database transactions. A transaction is a program unit whose execution may or may not change the content of the database. It may or may not change the content of the database. That is the first point. The transaction is executed as a single unit. If the database operation does not update database but only retrieve data, this type of transaction is called the read-only transaction. You're trying to fetch only the data, not trying to update. Then it is called as a read-only transaction. A successful transaction can change the state, change the database from one consistent to another. As you seen earlier, before transaction it is inconsistent. After database it is consistent. Between this phase it is inconsistent. The database transaction must be atomic, consistent, isolated, and durable. That is asset properties. A represents atomic, C for consistent, and I for isolated, and D for durable. These are the asset properties. If the databases were in inconsistent state before transaction, it could remain in the inconsistent state after the transaction. So suppose something database has been corrupted. So before transaction it is in inconsistent. After the transaction also it will remain in inconsistent state. Now, why do we need concurrency in transactions? A database is a shared resource accessed. Database is a shared resource accessed. It is used by many users and processes concurrently. For example, the banking system, railways and air rail systems, stock market monitoring, supermarket inventory and checkouts. So all these are various types of systems where we used database, and at all this point there will be multiple processes and concurrent users running. Now, not managing concurrent access may create issues like hardware failure and system crashes, concurrent execution of same transaction, deadlocks, or slow performance. This is the why we need concurrency. Now let us see an example of a transaction. A transaction is a set of related changes which is used to achieve some of the asset properties. The transactions are tools to achieve the asset properties. A transaction can be defined as a group of tasks. A group of tasks can be defined as transactions. A single task is a minimum processing unit which cannot be divided further. A transaction in a database system must maintain atomicity, consistency, isolation, and durability, commonly known as asset properties, in order to ensure accuracy, completeness, and data integrity. Now let us take an example of a simple transaction. When suppose a bank employee transfers 500 rupees from account A to account B. This is a series of steps here. Here is you want to transfer from one account to another account an amount of 500 rupees. Now this is very simple and small transaction, involves various low level tasks. Now first see we have two accounts, account A, account B. First he opens account A. He says old balance is equal to the current balance. Now he says the new balance is equal to minus 5 because we want to transfer 500 from A to B. So he says minus 500. So after that he says A dot balance equal new balance, close the account. Okay. So he's opening account, he's checking the balance, and he's minusing 500, and after that he's updating the new balance. Okay, this is related to account A. Similarly, if you see, now we have to add this 500 to the account B. Open account A, B, old balance equal to B dot balance. Okay, this is existing balance. New balance is old balance plus what we have received from account A, that is 500. B dot balance equal to new balance, close account B. This is a simple transaction process. How you can transfer A to B. What are serious steps involved in this process? Now let us see the states of the transaction. As you know, acid properties. Okay. Now apart from acid is nothing but I will see later said atomicity, committed, isolated, and what durability. Now, during the phase of transaction, we have various states. Those are active state, partially committed, committed state, failed state, terminated state. The active state is that the transaction enters in the active stage when the execution process begins. So whenever your transaction begins, then it enters into the active state. During the state, read or write operation can be performed. Now, what is the partially committed? A transaction goes into a partially committed state after the end of the transaction. So activity is performed when we start. Partially is partially committed is at the end of the transaction, not completely committed. The committed state is when the transaction is committed to state, it has already been completed execution successfully. Moreover, all the changes have been recorded to the database permanently. When all those changes are updated to database permanently, it is a committed state. So active state is starting, committed is ending, and between before coming to database, it is partially committed. Similarly, we have a failed state. A transaction considers failed when one of the checks fails or the transaction is aborted while it is in active state. Suppose you want to transfer A to B, and suppose we don't have that B account is not opening, then it is in a failed state. So again, the amount goes back to account A. The terminated state. The state of what is terminated state? The state of transaction reaches terminated state when certain transactions are leaving the system cannot be restarted. Suppose by any chance system got hanged or then system cannot proceed further. Then it is also in a terminated state. But failed state we can make it back to active state. Suppose if you open the account B and if it is successfully, then it is a failed state. But terminated state means the system, the transaction cannot leave because the system cannot be restarted. Now we'll see the various phases. So begin transaction. This is here. We have ending. We also know that something called partially committed. Then we have the committed. Okay, terminated. This is all we discussed in earlier slide. Only let us study the state transaction diagram that highlights how transaction moves between various states. Once the transaction starts execution, it becomes active. It can issue read on write operation. That is the first step of active state. Okay. Once the read and write operation complete, the transaction becomes partially completed. As we know that once before completing fully, it is in partial. Third, when some recovery protocols need to ensure that system failure will not result in ability to record changes in the transaction permanently. If the check is a success, the transaction commits and enters in a committed state. When some recovery protocols will make sure that system failure will not result in the ability to record changes in the committed system, then the check is success and it is a committed state. If the check is failed, when that recovery protocol check is failed, it goes to the failed state. If the transaction is aborted while it is in active state, it goes back to the failed state. When it is in active state, if it is aborted, it goes to the failed state. It goes to the failed state. The transaction should be rolled back to roll back to undo the effect of its write operation or database. So when it is in failed state, we have to undo the changes because it is not proceeding further. So suppose you try to try to deduct 500 rupees from account A. As we are unable to transfer to B, we should roll back to the amount back to the user A. The terminated state refers to transaction leaving the system. Suppose, for example, you try to go to ATM, try to withdraw money. You try to withdraw money about 500 rupees from your account, from your own account. But by some failure, the system, the ATM did not give back the amount to you back. So at that time, you'll receive a message that the transaction has been failed. You'll get back the amount after a few days or few hours. That is the asset properties on transaction. Okay. The asset properties of the transaction are as follows. First is atomicity. These properties states that the transaction must be treated as an atomic unit. That is, either all of its operations are executed or none. It is treated as one atomic unit, whether all pass or nothing is executed. There must be no state in the database where the transaction is left partially completed. State should be defined further, should be defined either before the execution of this transaction or after the execution, abortion, failure of the transaction. When an update occurs to the database, either all or none of the updates become available to anyone beyond the user application performing the update. This update to the database is called as a transaction, and it either commits or aborts. This means that only a fragment of the updates cannot be placed into the database should a problem occurs with either the hardware or the software involved. So the main it is an atomic unit where it is something it should all be successful or nothing should be successful. Okay. Suppose if it is successful, it is committed. If not, it is aborted. That is atomicity. The consistency. Consistency is an asset property that ensures that any changes to values in an instance are consistent with changes to other values in the same instance. The database must remain in the consistent state after any transaction. No transaction should have any adverse effect on the data residing in the database. If the database was in consistent state before the execution of the transaction, it must remain consistent after the execution of the transaction as well. For example, we may have a table or record in which two transactions are trying to read or write at the same time. Careful mechanisms are created in order to prevent mismanagement of these shared resources so that there won't be any changes in the way the transaction performs. A transaction which deposits 100 rupees to an account A must deposit the same amount whether it is acting alone or in conjunction with another transaction that may be trying to deposit or withdraw the same amount from other same time. Okay, this is consistency. Isolation. In a database system, when more than one transaction are being executed simultaneously and in parallel, one transaction is executed simultaneously and also in parallel, the property of isolation states that all the transaction will be carried out and executed as it is one only transaction in system. That means each will be executed separately. Okay. For example, user A withdraws 100 rupees and user B withdraws 250 from Z account, which has a balance of 1000. So A and B are trying to withdraw amount of 100 and 250 rupees from Z account, who has a balance of 1000 rupees. Since both A and B are withdrawing from the same Z account, one of the user is required to wait till other transaction is completed, avoiding inconsistent state. Now B can withdraw 250. After this, the balance is 900. First A will withdraw 100 rupees. Till then, B have to wait. After A is completed, the B will withdraw from this 1100 minus 1000 minus 100, 900. The last property is the durability. The database should be durable enough to hold all of its latest updates even if the system fails or restarts. If a transaction updates a chunk of data in the database and commits, the database will hold the modified data. If the transaction commits but system fails before data could be written to the disk, then the data will be updated on the system swings back to action. The features to consider for durability are recover to the most recent. The following are the features to consider for durability: the recovery to the most recent successful commit of the database software failure, the recovery to the most recent successful commit after an application software failure, the recovery to the most recent successful commit after CPU failure, the recovery to the most recent successful backup after disk failure, the the recovery to the most recent successful commit after database after disk failure. These are the various five steps to consider for durability. Example of an asset transaction begin x is equal to x plus 50, y minus 50. So this is one transaction. The second transaction is x is equal to x is equal to 1.1 times into x, y is equal to 1.4 times into x. The transaction 1 is transferring 50 from account to y to x. So from y we are minusing 50, we are adding to x. The transaction is trying to credit each account with an 10% payment, 10% interest payment. If both the transactions are submitted together, there is no guarantee that transaction 1 will execute before transaction 2 or vice versa. Irrespective of the order, the result must be as if the transactions are taking place serially one after another. What is a schedule? A schedule is a process creating a single group of multiple parallel transactions and executing them one by one. It should preserve the order in which the instructions appear in each transaction. If two transactions are executed at the same time, if the two transactions are executed at the same time, the result of one transaction may affect the output of other. For example, initial product is equal to initial product quantity is 10. The transaction is update product quantity to 50. Let's read product. Next transaction is read product quantity. If transaction 2 is executed with transaction 1, outdated information about the product quantity will be read. Hence, the schedules are required. Parallel execution in the database is inevitable, but parallel execution is permitted when there is an equivalence relation among the simultaneously executing transactions. This is of three types. One is the result equivalence. If the two schedules display the same result of execution, it is called as the result equivalent schedule. They may offer the same result for some value or different results for another set of values. For example, one transaction updates the product quantity, other updates the customer details. This is the result equivalence. Now, what is a view equivalence? View equivalence occurs when the transaction is in both the schedules performs a similar action. For example, one transaction inserts product details in the product table, while the another transaction inserts product details in the archive table. This transaction is same, but the tables are different. The conflict equivalence. In this case, the two transactions view the same set of data. There is a conflict among transactions as the order of execution will affect the output. Summary. Okay. A transaction is a logical unit of processing in DBMS which entails one or more database access operation. It is a transaction is a program whose execution may or may not change of the content of the database. Not managing concurrent access may create issues like hardware failure and system crashes. Active, partial committed, failed, and terminate are the important transaction states. The full form of ACID is atomicity, consistency, isolation, and durability. A schedule is a process creating a single group of multiple parallel and executing them one by one. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.